Recording in progress.
Okay. Can you tell me which question I gave you? The first one. What was the first one in the bonding?
The first one you gave me, it was like for
Magnesium oxide?
MgO.
Okay,
Yeah,
that was
magnesium oxide.
magnesium oxide. Okay. Now we are going
Yeah.
to look into how it will follow duplet rule, okay, or whether it will follow octet rule. Okay. This is what we have to check. Duplet rule means if by losing any electron or by gaining electron, there are two electrons in the valence shell. Okay, if there are, you just have to check the
Yeah.
valence shell electron. If there are two electrons in valence shell, it means that species is following duplet rule. Okay, two electrons in
Yeah.
valence shell. And if any species have 8 electrons in its valence shell, then we will say that species is following the octet rule. Okay, 8 electrons in the valence shell, right? Are you clear till this? This is simple.
Yeah.
Okay, now we are going to start with, let's see what is happening in the magnesium oxide. Firstly, we will start with the magnesium. As you know, magnesium is 12 and 24 is its atomic mass. So it means there are, its proton number is 12. So how many electrons will be there?
Like proton number
Yeah,
for
electrons.
magnesium
Electrons,
is 12. Electrons will be 12.
electrons will be 12, right? So how we will
Yeah.
write its electronic configuration? We will write it like this: 2, 8, and then hmm,
2, 8,
yes,
2, 8 for
not 4,
magnesium will be
2, 8, and
2, 8.
2, 8, 2, isn't it?
Yeah. Yes.
Total, we have to make it 12, right? The electronic configuration,
Yes.
electronic configuration, what is electronic configuration? Simply we say how electrons are
Like
distributed.
the
Simply, how
yes
electrons are
in the
distributed in the
shells.
shell. Yes. So in the
Yeah.
first shell, there are 2 electrons, that is K shell. In the second shell, there are 8 electrons, that is L shell. And in the third shell, there are 2 electrons that is known as
Yeah.
M shell. Now you
Yeah.
see there are 2 electrons in it. Okay.
Yeah.
What is the possibility for this? To if we are not talking about oxygen or anything, simply look uh, to this electronic configuration and tell me there can be two possibilities. One possibility is that it can gain 6 electrons, okay,
Yeah.
to make
Or
octet
lose 2.
complete, or it can lose two.
Yeah.
So which one is the best
Yeah.
possibility?
Lose 2
Lose electron. Okay. So
because
now,
it's easy.
yes, it is easy to lose 2 electrons. So we can write here, it is easy for magnesium
Mhm.
to lose 2 electrons. Okay. After losing 2 electrons, what will now it become? It will be converted into, it is magnesium, right? Neutral atom. It is magnesium atom.
Yeah.
Now it will be magnesium 2 plus 2 electrons.
Mhm.
And why it is 2 plus?
Yeah.
Because if we see, now you will check how many protons are there now. How many protons are there?
Protons, right?
Mhm.
Still 12.
Protons are still 12. Okay. And how many electrons are
Yeah.
there?
It lost like 2 electrons, so now 10.
Now 10. So which species more? Protons or electrons?
Protons.
How many protons are more?
2.
2. That's why there is +2 charge. Okay.
Mhm.
Now, what will be the electronic configuration now? It has loose electron. Okay. So it will be 2 into 8. Now there are 10 electrons, right? Isn't it? Now there are
Yeah.
10 electrons. So you will write it like
Yeah.
this and there will be this charge on it. Okay. Remember this thing. This is very important.
Yeah.
Whenever you are writing the electronic configuration of ion, you will write charge on it. Okay. Like this. Clear?
Yeah.
Now look into this and now tell me which rule magnesium is following now. How many electrons are
Uh,
in its valence shell now?
Now it's 8 to 8.
8 electrons. So it means which rule
Yeah.
it has followed? The octet or duplet?
Octet.
Yeah. So this
Octet.
is octet rule. It has followed the octet rule.
octet rule.
Okay. Now we will look into the oxygen. So we have oxygen,
Yeah.
and there is what is the atomic number and atomic mass of oxygen? That is 8 into 16, right?
Yes.
So there are the proton number is 8, electrons are also 8, right?
Yeah.
So the electronic configuration will be, what will be the electronic configuration?
And like now it will be 2 8
2, not now,
2
it
6
is neutral.
6
It
6
is
6.
yeah. Okay, it
Uh,
is 2 into 6. This is neutral.
yeah.
Now after this, what can we check now? There are 6 electrons.
The electrons.
Hmm.
Yeah.
So what is
The
the best
electrons will be
possibility?
changed.
What is the best possibility to gain 2 electrons or to lose these 6 electrons?
To gain 2 electrons.
Hmm. So it is easy for this to gain 2 electrons. So
Yeah.
it will gain 2 electrons. It will. Okay. Now it will gain 2 electrons. So it will become now. This is oxygen. It has gained 2 electrons. Now it will be written as like this. O2 minus, right? And
Yeah.
what will be the electronic configuration now? You see, originally there were 8 protons, but now it has gained 2 electrons. So how many electrons are there now?
If it gain two electrons, it will be
Hmm.
8 now.
So there are, no, oh yes,
No, 10 10.
10.
No, 8 8. Yeah. Yeah.
Wait a minute,
Wait,
there are
no.
8,
If it
and so it will be
yeah
10 now. 10.
10. Oh, I thought from 6. Okay.
Hmm.
No.
10 electrons. Okay, so there are 10 electrons now. It means there are 2 extra electrons, right? There are 2 extra electrons.
Yeah.
So what will be the charge now?
Minus, like 2 minus.
Minus, 2 minus, right. So you
Yeah.
will have 2 into, what will be the electronic configuration now?
It will be now 2 8 2.
2, 8, just 2 and 8. Why 2, 8, 2?
Yeah, 2 8. Yeah. Sorry,
2,
sorry.
8. Yeah. So look into this and tell me which rule it is following. How many electrons are there in the valence shell?
8.
8 electrons. So which rule it is
So it
following?
follows the octet rule.
Yeah, it is following the octet rule. Okay.
Yeah.
Are you clear with this?
Yes, yes.
If any species, for example, if we talk about this oxygen, I am just I am hypothetically telling you this is not possible. Actually, in actual, this is not possible. Let's suppose oxygen is losing 6 electrons. Okay, it is losing 6 electrons. So what will now left? There will be just 2 electrons left. Okay.
Yeah.
So which rule it will be followed then? Which rule it has followed?
Like if it's 2,
Hmm.
then it will be duplet rule.
Duplet rule. Yeah. This is what we say duplet and octet. Okay. This is not
Mm-hmm.
possible for oxygen to lose 6 electrons. I am just giving you the example. Clear?
Yeah.
Are you clear with this? Okay, now, and
Yeah.
one more important thing I was telling you that after doing this all, what you need to do, you need to write the final equation. Okay, final equation. What is final equation? This oxygen. Firstly, you will write
Mm-hmm.
Mg. Actually, you will write this whole Mg2 plus 2 electrons, and over these are on this side, and the electrons are cancelled, right?
Yeah.
Let me tell you how you write it. Firstly, we will write this equation Mg. It has converted to Mg 2 plus 2 electrons, and oxygen, it is now oxygen plus 2 electrons, and it is converted into O2 minus, right? These are the two equations. So
Yeah.
what will be our final equation? If we add these two equations, what you will get, that these 2 electrons are lost, right? These two, they are cancelled out.
Mm-hmm.
Okay.
Yeah.
And what you will get by combining these two, simply you will write it like this: Mg2 plus O2 minus, and you will get the MgO. Basically, I can write it like this: MgO. Okay. And how you get this MgO? By by combining Mg2 plus and oxygen 2 minus. Okay.
Mm-hmm.
Are you clear with this? Or simply
Yes.
you can simply write the final equation. Don't it is not required. Simply what you can do, take the ions, okay? what is the ion over here in the magnesium? This is the ion, right? This is the ion.
Mhm.
Take this, and this is the ion. This is anion. This is cation. This is
Mhm.
anion,
No.
right? And now what it will be known as? It will be known as now oxide. You will not say it oxygen, okay? This
Mhm.
specifically we say for anions, not for cations. This will be known as magnesium. We don't change their name. We don't change the name of cations. We change the name of anions. Okay. When
Mhm.
any neutral atom loses electron and it became anion, then it is known as oxide or chloride or hydride. Okay. Clear?
Mhm. Yeah.
Or just like we say sodium chloride. Why we say sodium chloride? Because chlorine in that is gaining electron and chlorine is becoming anion, right?
Mhm.
Okay. So we will write what we will write Mg2 plus, right?
Yeah.
Plus O2 minus. And
Yeah.
what I told you that you will exchange this valencies. Okay. When you will exchange this,
Yeah.
the charges are equal. So what will happen? You will have just MgO. Okay. Plus
Mhm.
plus 2 minus 2 is neutral, right? We will get this.
Yeah.
Clear? This is the final equation. This is what I
Yeah.
was telling you that you need to write the final equation. You need to show that
Mhm.
actually this is the bonding which is happening. Okay.
Yeah.
Are you clear with this?
Yeah.
Okay. Let's do one more example. What I have given you the other example, you can tell me, and then we can do that. What was the question? I think there was potassium chloride. I don't remember. Can you check and tell me
For what? Uh,
the questions? Which
yeah, the question two is potassium bromine,
okay, that was
PbR.
potassium bromide. What is the electronic
Potassium.
configuration of potassium?
Potassium electronic configuration
19
is gonna
into
be
hmm,
two. No, it's from
atomic.
potassium
You
like
can. What is the atomic
potassium
number?
2881. The atomic number is
19,
39.
and yeah, that is 39. So what will be
And
the
proton
protons?
is 19.
Hmm. How many neutrons are
Yeah,
there?
19. No,
Neutrons.
yeah, no,
Neutrons.
20, 20,
20.
20 neutron.
Electrons are also 19. Okay.
19. Yeah.
And electronic configuration will always be of electrons. Okay, as the name indicated, electronic configuration. We see how many electrons are there. So it will
Mhm.
be 2,
Mhm.
8, then hmm, what will
2,
be?
8,
Hmm,
8,
hmm, and
1, 1.
so it will be K, L, M, N, right? There are four shells. So what is the
Yeah.
valence shell now? Which one is the valence shell?
1.
N shell. You will say N shell. N shell
And
is the
shell.
N shell is valence shell. Okay. Okay. Now, what is the best possibility by seeing this electronic configuration? What can be the possibility for it to have seven electrons, to gain seven electrons, or to lose one electron?
Lose 1 electron.
So it will lose one electron.
Yeah.
Did you get the idea why I am saying that whether it will gain seven
Yeah.
electron or
Yeah.
whether it will lose one electron? Okay.
Yeah. Yeah.
I am saying seven electron because the best possibility is to have eight electrons in the shell, right? In the first shell, there
Yeah.
are always two electrons, but after that, the possibilities of eight electrons, okay? Eight electrons in each cell, eight electrons. So that's why we see if there is one, it means it can have two possibilities, whether it can gain seven electrons or whether it can lose this electron. So this is the
Mhm.
easiest possibility. And why we are saying why we are doing this all? Why we are saying that it will lose electron? This-
Like, so I can lose 1, so it's easy.
Why it is losing?
Because, like, you, like, it can't gain 7 because it's already, what's it called, oxygen. Like, the valency shell, it won't be balanced.
No, I am asking why we are doing this all. Why there is need of potassium to lose electron and why bromine will accept electron. What's
So,
the
like,
purpose
the
behind?
valence shell. valence shell can be balanced.
Yes, because everything want to be in stabilized form. The elements want to be stabilized. In the individual form, the individual potassium is not stabilized. For stability,
Yeah,
it will make bond. Okay, for stability, it will make bond. So your answer should be
yeah,
for bonding purpose, they will lose electron. One species will lose electron, and the second
yeah,
species will gain electron for bonding purpose.
yeah.
And why they are making bonds? For stability purpose, to stabilize
Hmm.
themselves, because they cannot be alive in independent. They cannot be present in independent form. You cannot have the potassium in the individual form, and you also don't get bromine in the individual form. Okay, you will always
Yeah,
find these bonded with each other, or whether potassium will be bonded with chlorine or some other element. Okay, so that's why we have periodic table. In the periodic table we have different elements, and all those elements have different possibilities. Okay, like this potassium,
yeah,
it can make bond with bromine, it can make bond with chlorine, it can make bond with the iodine as well. Potassium iodide is also there. So there are different possibilities depending on the
yeah,
situation and depending on how they react with each other. Okay, what are the properties? Whether the potassium is much more compatible with bromine or whether it is much more compatible with iodine. Okay, so we see all this chemistry, and by using these things,
yeah,
we make different products. You know, there are different products in the industry. There are the plastic things or all
yeah.
these things. How we make them? We firstly go to this idea. This is the basic thing of everything. You
Hmm.
know the basics. The basics is that, well, firstly, you know what is happening at the atomic level, how many protons are there, how many electrons are there, what is the best possibility,
Yeah,
what is its melting point, what is its boiling point, whether we can
yeah,
place it in the air or whether we should freeze it. Okay, so every species have different properties. Every species,
yeah,
just like we have discussed in the animals, the kingdom in different kingdoms have different characteristics. Similarly, the elements in the periodic table, they all behave differently because they all are present at different places, and their protocols, we have to follow the protocols. Whatever experiment you are doing in the lab, you have to follow all the protocols. You firstly read the instructions. That's why lab instructions are very important. Just like the sulfuric acid, you cannot use concentrated sulfuric acid at all in the lab just for general experiment.
hmm,
You need to make it dilute because concentrated sulfuric acid is
hmm,
too much reactive. So these are the things
hmm.
which we study in the chemistry to make the different products. That's why I feel chemistry is
Hmm.
more fascinating as compared to other subjects. There are many things in
Yeah,
chemistry. Okay,
yeah.
uh, so the potassium, it will lose one electron. And now
One
what will be?
electron.
Yeah, what will be the new?
Oxygen will gain one.
Yeah, what will be the now
No, not
electron
oxygen.
configuration?
What's it called?
Bromine.
Now
Okay,
it will be 288.
yeah, we are writing for firstly we complete for potassium. Okay,
Okay,
it will
potassium.
lose one electron, so there will be
So
plus
it will
one.
be 288.
Yes, it will be 288. Which rule it has followed?
Uh, so it's 8. So it's called duplet.
Octet, octet.
Octet because it's 8, and
Octet,
2
yeah.
it's duplet.
Octet is from octa. You ever seen octagonal shape?
Oh
Octagonal,
yeah,
octa.
octagon. Yeah,
Octa
yes,
means
yeah,
there
yeah.
are eight corners. There are eight.
Yep.
So octa
Yeah.
means eight. Okay, it is from
Yes.
octa, octet rule. Okay, then yeah. Now we have bromine. Bromine is, what is the proton number, atomic number of bromine?
For
35.
bromine, yeah, 35 and 19.
35 and 19.
No,
No,
80 and 35.
yeah.
80 and 35.
19 cannot be there. It will always be more. Atomic
Yeah,
mass will always be more. Okay, now can you tell me how
yeah.
many neutrons are there? Neutrons.
Neutrons 45.
Okay, 45. Good. And electrons are also. How many electrons are there?
Electrons there are 19.
Electrons are 90.
19, 19.
How electrons are 19? This
Oh no,
bromine.
this is for calcium. Sorry. No, bromine, electron 35.
Yes. Okay. What will be the electronic configuration for this?
For this, it will be 2, 8, 18, 7.
Yeah, there will be 18 now. Good. And 7. So
7,
there
yeah.
are 7 electrons in the valence shell. What can be the two possibilities for it?
Gain one
Yeah, gain one or it can
or
lose
lose
7.
seven. Lose
So what
seven.
is best possibility?
Gain one from
Gain 1. Okay.
calcium.
Yeah, it
Yeah.
will gain 1 from the
Yeah, because calcium
potassium.
loses one and it
Potassium.
gives one. Yeah.
It is not calcium, it is
Potassium.
potassium.
Yeah.
For
Potassium
me,
loses one electron and gives one electron to the valence shell. So it will be 2, 8, 18, 8.
yes, it is.
Mhm.
Now it will be
Minus
2,
one. Yeah.
yeah, 2, 8,
2, 8,
18,
18, 8.
8. Which rule it has followed?
Octet rule.
Yeah, octet rule. Now, what will be the final equation? Simply, you will have potassium ion, right? Plus bromide ion, and it will form potassium bromide. Clear?
KBr.
Yes. Are you clear with this?
Yes.
Okay. Now
Yes.
we can check the what's next in the book. And
Recording in progress.
we are done with this electronic configuration. Okay. And yes, the most important thing I am going to tell you now about the group 8 elements. As I have discussed this earlier, that group 8 elements are this is a special group. Okay. These are known as noble gases. Okay. What they are known as? They are known as noble gases. Okay.
Noble gases.
And why they are known as noble gases? Because they are stabilized. They don't need to make bond with any other species. Why is it so? Because their valence
Yeah.
shell is full.
Hmm.
Their atoms have full outer shell. Okay, their atoms have full outer shell electrons. If you see this helium has two electrons in its valence shell. So which rule it is following? Two electrons in the valence shell.
Yeah. So duplet rule.
Yeah, it is following the duplet rule. Okay, there are just two possibilities, duplet or octet rule. And this neon,
Yeah.
so there are 8 electrons in the valence shell. If you see, the valence shell is the large shell. So there are 8
Yeah.
electrons. So it is
Yeah.
following the, which rule is it is following?
Uh, if it has two, it's duplet rule.
No, it is check the valence shell. How many electrons are in the valence shell of the neon?
Neon.
This one.
I can't like I'm still on the note that you're showing me. One note.
Oh,
I can't see the screen. Yeah.
now can you see this? Let me share the entire screen.
Yeah.
This is what I was telling you about the group 8 elements. The helium is following the duplet rule because there are 2 electrons in it, right?
Yeah.
What about the neon? This neon. How many electrons are in its valence shell?
Uh, 8.
8. So which rule it is following?
Uh,
Hmm.
octet? No.
Yeah,
Octet. Yeah.
octet,
Octet.
octet rule. There are just two rules, octet
8.
and duplet.
Yeah. 8
Now
electron. Yeah.
argon, yeah, argon. There are also.
But what if the valence shell has like 3 electrons or
So then
different pattern?
that species will lose electrons. Okay, and
Mm-hmm.
then
Okay.
in the atomic form there can be. You see, in the atomic form we have discussed that there are. You see, in the lithium
Yeah.
there was 1 electron. That's why lithium we have done. I have given you the homework of the lithium bromide. So that's why the lithium was losing 1 electron. Okay, the lithium was losing 1 electron. Why it was losing 1 electron? Because it has 1 electron in
So
the
it can
valence
be
shell.
balanced.
Yeah, so it can be balanced. Now,
Yeah.
when it will lose 1 electron, how many will be left behind? You check this. How many will left behind when it will lose 1 electron?
It will lose 1 electron. It will be only 2.
Two. So it will be following the duplet rule, right?
Yeah.
So this happens with all the groups except group number 8. In the group number 8, you
Mm-hmm.
have full shells. Okay, their shells are full. This is
Yeah.
what we are discussing. The group 8 is a special group. Naturally, they don't need to make bond. They are noble gases. Okay, they don't need to react. They are most stabilized one. That's why they are unreactive. Okay, they don't react.
Mm-hmm.
Normally, in normal conditions, they don't react. Why they don't react? Because they are full of electrons. They don't need to. do something. Just like I gave you the example of apartment. Like the people share apartment for the stability purpose,
Mhm.
so that half will can
Yeah.
one can they can equally share the bill. They can equally share all the expenses. But in this case, they don't need such thing. Why they don't need such thing? Because their valence shell is full. Okay, check the valence shell of argon. How many electrons are there in the valence shell of argon?
8
Eight. So it is following which rule?
octet.
Octet rule. Okay. So you see the helium. Helium, it has two electrons. Simply, it is following the duplet rule. Clear? Right?
Mhm.
And all other A group 8 elements will
Give
follow
me,
the.
give me 1 minute. I'll be back.
Okay. Okay.
Recording in progress.
Yeah, I was telling you about this, the group 8 elements. They are noble gases. Why they don't react? Because their valence shell are full. Okay, their valence shell is full.
Yeah.
That's why they don't need to react. The helium is following the duplet rule. Okay, the helium is following the duplet rule. All
Yes.
other are following the octet rule. Okay, all other the neon is following the octet rule. You see, 8 electrons are there. The argon is following the octet rule. There are 8 electrons in its valence shell. Naturally, it is there. If we see
Yeah.
this, where is there is periodic table. Let me, yeah, there is helium neon. This helium is following the duplet. Rest of the elements of this group are following the octet. Okay, these all are following the octet. Now your task is to write the electronic configuration for krypton and xenon. Okay, for krypton and
Okay.
xenon. Can you write this for krypton and
Yeah.
xenon?
So I have to write from krypton and xenon.
Krypton for
Hello.
the no, you have to do this for. I'm saying I'll write the electronic configuration for krypton. Okay,
For krypton and neon.
xenon. Yeah.
Oh, xenon and krypton. Okay.
Okay, krypton and xenon. And then you
Uh,
will check that there will be in the valence shell. I'm saying, I'm repeating in the valence shell there will be 8 electrons. Okay,
yeah. Yeah.
so it means what we get from this, that the group 8 elements are stabilized one. They don't need to
So
react. Okay, they don't need to.
so
Mhm.
I don't have to do like the protons atomic mass number. I just have to give like the electronic configuration. Yeah.
Configuration. You see, proton number is written over here. You check. You see this krypton. For krypton, it is written. The proton number is
Yeah. Okay.
36
I'll send
and
it to you
mass
after.
number is 84. Okay.
Yes.
Okay.